I asked 15 of my developer friends across different industries the same question. How do you program today? What do you do? Like, what does your job look like when you wake up, you get to the office, you work from home? What actually happens, right? Because it used to be that you would, you'd have your stand-up, you'd go through your tickets, your backlog, you'd maybe pick up a ticket, take a look at different ways of implementing things. You might sketch things out on a whiteboard. You might have to have a meeting to discuss with people the best way to build something. It was collaborative. I wasn't shocked to hear that they all said the exact same thing. But every single one of their workflows revolved around LLM agents. They'd start work, they'd still have stand-up, they would open up Cursor, Codex, Claude Code, Pi. They all have slightly different ways of using the tools, but they would sit down, have stand-up still, but then they'd pretty much all open up Cursor, Claude Code, Codex, Pi. They all have different tools, but they're all revolving around the same thing. They're all using AI agents, and they're not actually manually writing code anymore. A friend of mine who works at a great company, he hasn't actually written any code in 5 months, he said. He doesn't even touch a keyboard anymore because he just dictates using a whisper flow or spokenly. And that's his day now, right? And it's not just writing the code, it's writing tickets in linear. You can use the MTP for that. It's writing the code itself, it's writing unit tests, it's testing it manually. You don't really have to test your code in the same way anymore. Yes, you'll still write unit tests, you'll still write integration tests, but the execution of those tests and the loop that actually writes these tests, it can now all just be automated with an LLM. And even after that, there's the code review, right? So typically, if you're working in a team, you'll submit your code using a pull request to the repository that you're working on. You'll tag some people in your team, they'll have a look at the code, and then they'll give you feedback on it. They'll say, don't do this, they'll say edit that. Even now, a lot of these engineers are using LLM agents to do the code review. So we've got LLM agents writing the tickets, creating the code, reviewing the code, and then the engineers just sort of funnel that through. And I'm not saying this isn't useful. This is largely describing how I do my job. But the important thing is that we still understand how the code runs, right? We're responsible for the quality of the code, the maintenance of the code. We're the ones who get woken up at 3 a.m. to fix something if something explodes in production. So we still have to understand the code, right? Well, I'm Chris. I've been building software for 15 years, and I'm not sure if we need to understand things anymore. You see, I went to a meetup last week. There were engineers from all over the place, lots of different cool companies in London. And I started speaking to a bunch of them in this little sort of huddle. We were just discussing about how things are working these days. And we were discussing if the code is moving so quickly these days and the rate of implementation is increased so much, how can we make sure that our level of understanding keeps up with that so that we're going at the same cadence? And then someone said something really interesting. Someone asked, does anyone actually really understand their code bases anymore the way that we used to? And most people said no. They said, they still understand the general idea. They still held core principles about how their code worked in their heads, and they understood them from a high level point of view. But low level, a lot of the engineers had conceded that they just don't understand the code on a line by line basis anymore. Someone said to them, explain how this feature works in extreme depth, all the edge cases. A lot of these engineers conceded that they wouldn't be able to do that. They still understood it from a high level, and they understood the gotchas, they understood the different edge cases potentially in how it executes, and runtime issues that might come up from a result of some of the architectural decisions they've made. But many of these engineers just said, well, I can just ask the LLM to do that, which I think is sad. I think for the record, I think we should understand how our code works. I think it's fundamentally important, not just to preserve our usefulness as software engineers, but these LLMs make mistakes. But then someone said something really interesting. They said, why do we need to understand the code anymore? And everyone just sort of looked at him and thought, what are you talking about? And everyone sort of brushed off that opinion pretty quickly. But then we gave him a bit more chance to speak, and he managed to convince a few people in the room. See, his argument was that iteration has completely changed the equation now. Work that used to take a week to roll out now takes 2 hours to develop from start to finish. It'll be in production immediately. We have feature flags, you can roll back, deployments are small and incremental, and these LLMs are getting better than ever at actually programming and figuring out issues. They were arguing that the safety net used to be knowledge. Now the safety net is speed. They were saying that we're replacing knowledge with iteration. They argued that if you can ship at this pace, and you can observe metrics, and you can unit test everything immediately, and you can deploy, you can observe how your users are using your product. If something goes wrong, you can just roll back. You can turn the feature off with a feature flag. If something goes wrong that you can't fix programming-wise, you can fix it with Claude. You can fix it with Cursor, etc. They argue, do you really need to understand every bit of your code if the assumption is that you have these LLMs available to you? If one of them's not available, you have another subscription you can reach for. These LLMs can connect to production. They can connect to your Postgres instance. They can observe what's going on. They can look at Sentry. There are MCPs available to analyze and observe metrics, to debug issues as they pop up in production. So they asked, is that not better than slowing down to understand what's happening and just go quickly? I mean, Facebook coined move fast, break things 15 odd years ago. My counter argument was the 3 a.m. production issue. Your pager goes off at 3 a.m., you get woken up, you're disorientated, you don't understand what's going on. You might have slept badly that night anyway, maybe you weren't expecting something to come crashing down in production. Maybe you went out the night before and you're a little bit hazy, but these things happen. It's realistic, we're all human. And then you wake up, you look at your machine, the logs don't make sense, you have to parse everything, you have to figure out what's going on. And let's say your company only fits the bill for one agent. Let's say Cursor or Codex. Let's say both of these, or the one that you have access to, is currently unavailable. They're doing some maintenance. There's outages if you check the status site. So now you're running based on what you can understand and what you can figure out, and your knowledge. It's 3 a.m., your knowledge probably isn't going to be working that well, but it's probably going to be working better if you actually knew how it worked in the first place. And don't get me wrong, LLMs might be writing our code, but we should still be understanding the output. We should still be talking through how they're building this. We're catching things as they come up, we're steering them as we develop. I'd argue that you don't fully understand code unless you have written it yourself or have line by line gone through an implementation. You can have a surface level understanding of it by reading a summary after your LLM agent's finished, but you're not really going to understand why that line there is sorting this list before it moves it on to the next step. It might be 3 a.m., you might be disorientated, but I'd wager that if you had written the code yourself, you'd stand a better chance of understanding how it all works and what bug has appeared and what's happened. Deep understanding still matters, and I don't think we should be so quick to get rid of it. But maybe I'm wrong. I can concede that things are changing, and the code that you write one day won't be the same in a week. Other engineers in your team might improve things, they might refactor things. Performance optimizations happen, so parts of the code you thought you understood have changed. Systems evolve. So maybe none of us really understood the code base fully anyway. That's okay. Software's always been about abstraction. We had assembly, then we went to C. Frameworks exist. ORMs are available to help us work with databases easier. React, Phoenix, LiveView, and now LLMs. Maybe there's just the next abstraction layer. But the thing that worries me is, what if the LLMs disappear tomorrow? There are costs, there are rate limits, policy changes happen across governments, there are outages, whatever it is. How much engineering capability have we really outsourced? Open source LLMs are a huge answer to this issue, by the way. Right now, I can't spin up something on the level of 5.6 Sol on my personal machine. I can't spin up Fable locally, but it's getting better. Obviously, hardware costs are rising as well, so the capability to run these things locally is an issue potentially, but they are becoming more efficient. If you look at what open source models could do 2 years ago to now, the difference is astounding. And the tooling, the understanding, the ways of working with them is only going to get better. People will write software to make these things easier to work with locally. My take is, until we've actually managed to distill LLMs of the current quality from the frontier models today into our machines locally without being connected to the internet, then we should still keep in mind that if the phone rings at 3 a.m. and we have to fix something, it's on us to fix. Claude might not be available. I think maybe understanding hasn't disappeared, we've just taken a loan against it. We're optimizing for speed now, debt later. But you should really ask yourself, if your AI disappeared tomorrow, could you still build software the way you do today? I still think we should know how things work. Some people don't. That's a valid thought that I'm willing to debate and discuss, but I'd like to know what you think as well. If you have any comments, leave them below and then I'll get back to you, but otherwise, have a great day. Thanks.